Hi, Stat students. Today we're going to learn about a new probability distribution, and that is called the binomial distribution. And there are 4 rules for the binomial distribution that you need to know before we can begin. We need to be able to recognize if a situation is a binomial distribution, because we're going to learn another different probability distribution, and that's called the geometric distribution. So you have to be able to know what's the difference when you go and you find a probability for a question on your test, which will be coming up in the near future, right? Okay, so I have this acronym up here, BINS, and this first B, that stands for binary. Binary means the possible outcomes are either success or failure. So the best way I can think about this is if you are shooting hoops, you're either gonna make the basket or you're gonna miss the basket. Success or failure. If you're flipping a coin, you're either going to flip a heads or you're gonna flip a tails. If you're rolling dice and you want doubles, you're either gonna get doubles or you're not gonna get doubles. A success or a failure. I stands for independence. That means each outcome has to be, or each individual outcome, they don't affect each other. So if you make the first basket, that doesn't affect if you're gonna make the second basket. If you flip a coin and you get heads the first time, that doesn't affect if you get heads the second time, okay? N stands for the number of trials are fixed. So in the game, you're gonna shoot 10 free throws, or in the game, you're gonna flip a coin 10 times, or in Monopoly, you roll the dice twice, okay? There's a fixed number of trials for N. And then finally, S stands for success. The probability of success is the same for each outcome. So each time you try it, the probability of success is gonna be the same. I'm sorry, I'm stumbling over my words here. Okay, let's get cruising. What we wanna do first is we wanna be able to take this BINS and identify, do we have a binomial distribution or not? So let's look at this first example. We roll a fair die 10 times and let X equal the number of 6s. So we're playing a game, we want, a 6, okay? And so we're gonna do this 10 times and we're gonna record how many 6s did we get. So let's start with B. B stands for binary, success or failure. So again, like I said, we're rolling a fair die 10 times. We wanna know, are we gonna get a 6 or not? So our success would be a 6. Our failure would be not a 6. I stands for independence. Is each roll independent of each other? Does it affect the chances of getting a 6 the next time? Yeah, they are independent, so you just state rolls are independent of each other, okay? N, are the number of trials fixed? And they are, because it says we're gonna roll 10 times. So N is equal to 10 rolls. S, is the probability the same for each roll? Well, there's 6 sides on a die or a number cube, and one of those sides is a 6, okay? So yeah, the probability of success, a 6, is equal to 1 out of 6 each time. All of these are good. We have a binomial distribution, okay, for A. Yes, a binomial distribution. Okay, shoot a basket 20 times from various distances on the court. Let Y equal the number of shots made, okay? So we're gonna shoot a ball 20 times, various distances on the court. We're gonna record we either made it or we didn't. So B is our binary. B equals success would be we make it. A failure would be we miss it. Independence. If I miss one shot, is that gonna affect the probability of making another shot? Now, some of you athletes might say yes because it gets in your mind, but theoretically, no, that shouldn't affect it. So shots are independent of each other. N equals where we're gonna shoot the basket 20 times. Now, is the probability of success the same for each shot? So the probability of making it. Is that gonna be the same for each shot? Think about it. Hopefully your answer is no. Why? Because they're shooting from different distances on the court. For those of you who know basketball, you know that a three-pointer is a lot more difficult to make than a simple layup, okay? A free throw is easier than, a layup is easier than a free throw. A free throw is easier than a three-pointer. There's different shots that are easier to make than other shots, okay? So our answer is then, B was good, I was good, N was good, but S was not good. The probability has to be the same for each trial, okay? So for each shot, that probability has to be the same, and it wasn't. Okay, part C, observe the next 100 cars. Okay, or I'm sorry, let's answer this. No, it's not a binomial distribution. Observe the next 100 cars that go by and let C equal the color. So we're going to record the color. Was it red? Was it blue? Was it white? What color was the car? Well, B stands for success, failure. What is our success? Our success is the color of the car. So it's going to be red, blue, yellow, so on. What's our failure? I don't know what our failure is. All cars have a color. We're recording it. So no, this is not, it just right off the bat, this is not a binomial situation. I'm gonna let you try D on your own, and you can check with me if you're curious. I wanna move on now to the actual computing of a binomial distribution, computing probabilities of it. Okay, so I'm gonna teach you how to use your graphing calculator. That's gonna make your life a lot easier by knowing how to use your graphing calculator. And you're gonna have to pay attention to a couple different things, and we're gonna go through it right away. I want you in your notes just to kind of highlight this or underline this right now. P is equal to the probability of success. N is equal to the number of fixed trials. You need to know that. X is equal to the number of successes out of the fixed number of trials. And finally, the expected value of a binomial distribution is N times P. You're kind of thinking, what the heck is Ms. Opal saying right now? I don't blame you. Let's just go through the process and you'll learn along the way. I'm gonna go to the board right now to teach. And we'll go from there, okay? So the number of switches that fail inspection has approximately the binomial distribution. So they're telling us that we don't have to check it. We don't have to check it unless it tells us to. Like, we don't have to prove that the conditions are met. We just have to recognize that it is a binomial distribution. And this one is telling us that it is a binomial distribution. So we're gonna proceed, okay? The first one, it says find the mean and the standard deviation of the distribution. What I want you to put in your notes is the standard deviation is equal to the square root of n times p times 1 minus p. Okay, so you're putting that in your notes right now. My mean then of the distribution, of the binomial distribution, is n times p. So let's identify what n is. N is equal to 4. P is equal to 0.1. So I'm just going to take 4 times 0.1. Okay, 4 times 0.1 is equal to 0.04. All right, the next thing I'm going to do for the standard deviation is I'm going to take the square root of n times p times 1 minus p. Okay, so I'm going to put that in my calculator right now. Square root, it's right there. So second x squared, 4 times 0.1 times 1 minus 0.1, that's 0.9. And I get 0.6. Okay, the next thing I want to do, let's go down to part B. Find the probability that 2 fail. Now, here's what's really important, guys, is you have to use your probability statements or your life is going to be a little bit difficult. The probability that 2 fail. So that's the probability that X, okay, this capital letter X is the situation. What's happening? We're inspecting 4 switches. We want to know out of these 4 switches, so again, this is the story that's going on. We're inspecting 4 switches. And you don't need to necessarily write that down on your problems. I'm just giving you the context right now. We're identifying 4 switches. We want to know what is the probability that 2 of them fail. Okay, now what I want to do is I want to go up, and I want to go up and I want to say, okay, I know that I have an X is equal to something, okay? X is equal to something. In my calculator, I am going to use what's called a Binompdf. Binompdf. So I'm going to put Binompdf, okay? Binompdf. Again, in my calculator, I'm going to go do a Binompdf. I'm going to show you how to do that in 1 second. How did I know I'm using a Binompdf versus a Binomcdf? This one is an inequality. This one is an equal statement. And again, I am looking at, right, the question so I know, is it an equal or is it an inequality? That exactly to fail is an equal statement. So a Binompdf. So I'm going to show you on your graphing calculator where to find that now, and you all have a graphing calculator in your Chromebook. I'm going to go to my graphing calculator right now. I'm going to hit second. I'm gonna hit vars. So second is right here, vars is right here. I'm gonna scroll up and I'm gonna see my Binompdf right here. I'm gonna hit enter. Trials, that is the fixed number of trials that I have. That's 10. P is equal to the probability of success, okay? The probability of success, they told us in the problem, is 0.1. And then the X value, that's what's going on. What do I want? This is my X value right here, 2, what I put right here. So you can see up here, my little X value there. What did I put? That's 2. I'm gonna hit paste. And now, those of you who have the old graphing calculator, you're gonna hit enter in Binompdf, and you're gonna actually have to type this in. So you'll have to type in 10, comma is right here. Type in next the probability. That's right here. And then your little x, what are you looking for? You're looking for 2. On your homework, ladies and gentlemen, I do want you to show me that calculator speak of what you typed in. 10, comma, 0.1, comma, 2. This was my N, this was my P, this was my X. Then you're going to go ahead and you're going to hit enter on the calculator. And I get 0.1937. It's okay, we're going to round to the nearest hundredth in regular stats here. If you're watching from AP Kids, you want the third or the fourth decimal place, okay? So 0.19 is my final answer there for part B. Let's go to part C now. It says, what's the probability that at most 2 fail? Okay, when you don't have an equal statement, what I want you to get used to is I want you to write down all the options of what could happen. So I have 4 light switches total. That means all 4 could fail, or 3 could fail, or 2 could fail, 1 could fail, or none could fail. When you read things that are not an equal to, that are an inequality, I want you to list out all the options that could happen. 0, 1, 2, 3, or 4. If n was equal to 10, you'd have to go up to 10. If n was equal to 20, you'd have to go up to 20. But trust me, it's an important step. The next thing it says is, what's the probability that at most 2 fail? Well, at most, I'm going to highlight what that is or circle. At most 2 would fail is right here. At most 2 would be 2, 1, or 0. That means when I write my statement now, I am writing, I want the probability that x is less than or equal to 2. Okay, that x is less than or equal to 2. So what am I doing? If I go up here, I look, well, because I have an x is less than or equal to 2, I'm going to use a Binompdf. A Binompdf. I'm going to go to my calculator now. I'm going to hit second, vars. I'm going to scroll up to Binompdf. My trials are 10. My probability is 0.1. And my x value is 2. I'm going to go ahead and I'm going to paste again, and I get 0.9298. I'm going to round 0.93. Again, I'm going to put 10, 0.1, 2. This is what I typed into my calculator. This is how I'm going to show my work, and I have 0.93. Okay, there's my final answer. Let's move on to the next one. What's the probability that at least 2 will fail? Here's where we're going to get a little bit more difficult, ladies and gentlemen. 0, 1, 2, 3, and 4. At least 2 will fail is 2, 3, or 4. Okay? And when I write that as a statement, that's the probability that x is greater than or equal to 2. Well, if I look at my CDF, ladies and gentlemen, if I look at my statements up here, the CDF only works for a less than or equal to. So when we have a greater than or equal to, we have to use what's called the complement rule. We need to do, whenever it looks like this, or a greater than, which we'll do here in a second, we need to use the complement rule. The complement rule, remember, is 1 minus the probability of what I don't want. I want what I circled or rectangled here. I want that. I do not want this. That's what I don't want, ladies and gentlemen. So whenever you see something like this, you have to go to this step here. You have to figure out what you don't want. I'm then going to rewrite it in terms of an inequality. I want 1 minus the probability that x is less than or equal to 1. How did I know 1? Because 1 was the highest number that I don't want, and I don't want anything less than that. Okay? Now what I have is I have something that's set up to a less than or equal to, which will match what I have up here. I want a less than or equal to in order to use my calculator. So I'm going to go and I'm going to say, okay, well then this is a 1 minus a binomial CDF, because this part I can use a CDF right now. So let's go to our calculator and let's do that. I'm going to hit 1 minus a CDF, second vars, binomial CDF, okay? I have 10 trials, 0.1. Now I need to change my x value to 1. Why do I need to change my x value to 1? Remember, I want 2, 3, or 4. That's a greater than or equal to. I need to do the complement, 1 minus what I don't want. At the 1, 0, okay? At most 1 or 0, that's x is less than or equal to 1, and that matches up with my binomial CDF. That's my little x there. If you go back up and scroll up here, oops, sorry guys. That's that little x right there, okay? So let's go ahead. Let's hit paste. Those of you with the older calculators, again, you're gonna have to type that in again on your own. So it always goes NPX like that, NP little x. Okay, I'm gonna hit enter and I get 0.26. So binomial CDF, 10.11, that's our NPX, which is equal to 0.26, final answer, okay? Let's do 2 more together and then we are done for the day. What's the probability that less than 2 fail? Again, anytime you have an inequality, not an equal to, but an inequality, write out all your options just like I told you in part D, and I believe we did it in part C as well. Yes, we did. Okay. Let's write out all of our options. We have 0, 1, 2, 3, and 4. Again, how did I know to stop at 4? Because that's what my n was, okay? That's what my n was. What's the probability that less than 2 fail? So what I want is right here, less than 2. I can write that as a probability statement as the probability that x is less than or equal to 1. We are in luck now because it's a less than. We do not have to use the complement rule, the 1 minus the probability of frowny face, what I don't want. We can go ahead and compute here. This matches up perfectly with what we can use our calculator for. Right up here, okay? We're gonna use a binomial CDF. Again, this is how we're gonna show our work on a test, guys. Binomial CDF, we're gonna go to our calculator again. Second vars, binomial CDF, hit enter, okay? Our trials are 10, our probability is 0.1, and our x value that we have right here in our inequality, that's why it's important to write that inequality out, is 1. I'm gonna go ahead, I'm gonna paste, and I get 0.74. 0.74, so I have 10.1, comma 1, NPX, 0.74. All right, ladies and gentlemen, let's go to the next one. What's the probability that more than 2 will fail? Again, this is not an equal to. We're gonna write down all of the options. That is 0, 1, 2, 3, or 4. More than 2 will fail. This is what I want. Okay? This then, when I write, I'm always writing my probability statement on all of these. If you look at all of them, I can't scroll up right now, but every time I highlight, I write down the probability statement. This right here is the probability that x is greater than or equal to 3. Well, a greater than or equal to, I need to use the complement rule. Remember, any inequality, the calculator only works When I scroll up, just as a reminder, you can never see it too many times, it only works for that less than or equal to. So I need to rewrite it. I'm going to do that complement rule. I'm going to do 1 minus the probability of what I don't want. What don't I want? I don't want here. So I'm going to rewrite that. 1 minus the probability that x is less than or equal to 2. Now I have it set up the right way for the calculator, okay? So that's going to be 1 minus a binom CDF. Let's go ahead. Let's type that in our calculator now. 1 minus binom, second vars. Hit enter, 10.1, and now I want 2 this time because that's that number right there in that inequality. That's why it's so important to write that inequality out the correct way. I'm going to paste and enter. I get 0.07. So 10.1 and then 2. NPX equals 0.07, I believe. Okay. All right, ladies and gentlemen, we should have learned about what a binomial distribution is, what are the 4 conditions for it, and how to use our calculator to compute probabilities that are a binomial distribution. Have a great day, guys. Make sure you ask me any questions that you have, and we will chat soon.